Good morning, everybody. It's 55 degrees today. More excitement than that. Good morning. There we go. Now, of course, it's going to snow tomorrow, but, such is our life. All right, so for on-campus students, there will occasionally be an attendance question that I will ask you about, and there is this week. So at the bottom of the folder, there's an attend. My question for this week is, have you bought Cengage? So if you're online, you do not need to use those. That's just my way of able to put it very quickly into Bobcat 360. All right, so we started this adventure a little bit, and we said, all right, we're going to use Python. Great. But before we get to Python, we need to know a little bit more about a couple of things. And so there's some terminology, and we also need to kind of understand how that computer works at a basic level so that we can start to figure out how we can implement our programs. As a quick note, our computers are the dumbest things you have ever seen. There is no intelligence in a computer. It is really nothing more than a set of light switches. So as we go through here, we're going to figure out how we can use that then to create content and to allow us to make some decisioning. So first thing we want to look at is the idea of an algorithm. So we've heard the term algorithm. Algorithm really just means a set of rules that allow us to process. So in our own life, we have an algorithm. If we're driving down the highway at 75 in a 65, and I see a police officer in front of me, what do? I slow down. That's that algorithm. I see something, I see a condition, I change my behavior. Our thermostat has an algorithm. If it's set to 75 degrees in heating, and it's 70 degrees, it sees that and it says, aha, I turn on the furnace for a while. In this case, there's an algorithm here for subtracting numbers. So we write down the numbers, we start with the rightmost column. So these are things that you guys have all done. You didn't maybe call it an algorithm, but in this case you said, hey, that's a pattern when I add, subtract numbers, when I multiply. So my 10-year-old is very frustrated right now in math because they're multiplying like 3-digit numbers times 3-digit numbers, and she can't just write an answer down. She has to follow this pattern, and she hates it. It's that idea of that algorithm. So what we need to do is break down things into an algorithm, or create one that will solve whatever problem we're trying to get to. So, what kinds of things are in an algorithm? So we have a set of instructions. They're well defined, and they solve a process. We do this all the time. And if you think about something as simple as, and I always like to use the example of taking a shower. If you do things out of order while you're taking a shower, it's not going to go very well. So if I get into the shower and I still have all my clothes on, that's going to be a problem. In most places, if I turn on the water once I get into the shower, it's kind of a pet peeve of a lot of movies. How many movies have you seen where somebody gets in the shower and then turns the water on, spraying right on them? I don't know what shower they've got, but if I do that in mine, I'm going to have this shot of scalding cold water that's going to freeze me, and I don't know how long I'm going to be standing there. So we have a specific order that we're going to work on material in. So this information that we're going to work with, a lot of times we also have a term called data. So you guys have heard that term before, but we also have some other things we need to work on. And so typically, our computer works with the idea of something coming in, and some kind of a process that occurs, a transformation, and then we get something out. So think of a calculator as a good example of that. When I pull up on my calculator, I push numbers in, that's my input. It processes them according to whatever I ask it to do, and then I get an output, and it's back then on that screen in most cases. So all of these things we're going to do So whether it's we want to create a TikTok video, or we're creating music, or whatever it is we're doing with our computer, we're writing a word paper, all of that really starts with that idea of we're taking pieces of information in, processing it, and taking stuff out. Our computers typically have a couple of different aspects to them. We break those down kind of in one division. We say here's hardware and here's software. So software is what actually runs, so it's our set of algorithms. The hardware is what it runs on. And we have a lot of different hardware platforms that we can look at. Some of you are probably using a Macintosh, some of you are using a Windows PC, maybe some of you are on a Chromebook, maybe on an iPad. Those are all pieces of hardware that then some form of software runs on. So, what is typical in every computer at this point? We haven't changed a lot of this, even though we've come up with new things like Macintosh has got this new thing called an M1, which has some differences, but they all work basically the same. So we have what's called a CPU, processing unit, central processing unit, whatever you want to call it, input, output, and then at someplace off to the side, it stores things in memory. And those memory is like a little set of buckets. And we're going to get to how we describe all those things. So your CPU, you could have a new Mac with an M1 processor. You could have went out and bought a new computer with the Intel i9 or whatever. The AMD has processors. So my computer station up here is running what's called an AMD Threadripper. So in this particular case, not only do I have one CPU, but essentially I have 64 on this particular computer. And that's one of the changes. We're going to multi-CPUs. So you may have 4 threads, or 8 threads, or 16 in a computer. Well, for what we're going to do, that's not going to change a whole lot of where we're at. But we need to figure out how to get input in and input out and some way to use that memory. So our input devices, we can have a lot of different types of input devices. What might be one input device we use? What's the most common input device we probably use? Keyboard. So keyboard and mouse are a set of inputs, but we're getting more sophisticated. What might be another way to input something? What other things can we use? What about a touch screen? What about your voice? Can we put data in? There's all kinds of other things. Maybe we're actually taking the input off of a video camera, like a security camera up there on the wall, and we're taking that video input in and multiplying it or changing it and looking for things. So our input can be in a lot of different ways, and so can our output. So the most common output we think of is probably that screen. But are there other ways to output things? I really like the output of my iPhone paired with a set of headphones. That music, that's an output from that computer. Maybe I need to print something. Right now I'm printing all my papers for taxes. So we have a way to print things out. So input, output, and then this is where it gets a little tricky, is this idea of memory. So I said our computers are really, really dumb. They can only handle zeros or ones. That's it. In fact, when you hear the term binary, that's what it really means, is there's only 2 numbers. Or if I hear the word decimal, or digital says I have zeros and I have ones. That's all. Our computer can handle nothing else other than zeros and ones. At the very basic level of this computer, it's a set of light switches. And the memory is that set of light switches and how we have them flipped. So the internal memory, you may also hear it called random access memory. It is really what we call volatile. In other words, when I power my computer off, it goes away. So that's what we call that random access memory. The second part of memory that we can have is some kind of storage or an external drive to the CPU. So if I have a hard drive on my computer, which everybody does now, so typically now they're solid state drives and I can store a lot of information on it. So That's the second piece. So there's random access memory, that stuff we use, and then there's some kind of storage. Our memory really looks like this. So if I look at this group, this computer memory is set up to store zeros and ones. So if I think about that memory as a set of buckets, how many buckets we have determines how much memory we have. And all they can hold are zeros or ones. Well, a 0 or 1 doesn't tell us a whole lot, but we can add them together and group them together to make them useful. So we have a couple of terms that you need to know. And so the first term is each one of those zeros or ones is something called a bit. So a bit, a 0 or 1, isn't very useful by itself. I can convey very little information that way. However, if I combine 8 bits, it equals a byte, B-Y-T-E. So a byte is a string of 8 zeros or ones stored on our computer, and they can give us the ability to start to process information. Because this byte, this group of 8, so we only have 2 positions. So I'll try not to do too much math, Taylor, because but everybody can multiply by 2, right? That won't bring any PTSD. I have a student who's a math major, and she has some PTSD when we start talking about that. So all we're going to do is multiply by 2. So if I multiply 2 times 2 times 2 times 2 times 2 times 2 times 2, so 8 times, I get a number of what? What is 2 to the 8th power, or 2 multiplied by itself 8 times? I'll let you off the hook this time. It's 256. Well, at 256 possibilities, a byte becomes kind of useful because we can store information in a byte, B-Y-T-E. And one of the first things we're going to store is things like numbers and letters, because all of those will fit in that space from, and here's where it's a little confusing, and we're going to run into this in class also. The computer starts counting at 0, we start counting at 1, correct? Okay, let's just throw that out there. So there's 256 possibilities, or 0 to 255 as number possibilities. Well, I can store an alphabet in there. I can store numbers in there. So this is the smallest unit of data that's actually usable for us. And it's called a byte, B-Y-T-E. So that's 8 of those altogether. Now, what this shows is something very similar, but it shows it as 16. So you'll find that we have a lot of different powers of 2 in our computers. And you'll see that we use 16. And in fact, the other reason we use 16 is 16 uses something very, very useful. So this is binary. If I have base 16, it's called hexadecimal. And it's a way that we can represent some numbers a little quicker. So we think in decimal, our computer thinks in binary. So we do have to be aware of that challenge. So when we have our computer code, it gets stored here as those zeros and ones, as a set of those, and a string of data. Our software grabs that string and says, all right, I know where I begin, because each one of these has an address, and I know where my computer begins, and I know where that software ends, so it's going to run it based on that. Well, I like binary, but if I had to program my computer in binary, it would drive me crazy. It's not very user-friendly. So what we built are things to set in between us and putting in zeros and ones all by ourselves. And what we built are programs that actually allow us to create other programs. So we built things like C++ and Python. at the very heart of them, they're actually a program, but we're using them to create another program. So the higher the programming language, the closer it looks like English. And you're going to find Python looks a lot like English. So, high-level programming language, very close to English. We can also do things like we use a text editor, and we're going to show you a couple of those. So, history. Read it, know it, memorize. No, you don't have to memorize all that. I just want you to be aware of how quickly this has all become. Because a couple hundred years ago, we had algorithms. People had figured out, hey, I need a standard set of instructions to do things. But we didn't have any way to run it. It wasn't really until we got into the 19th century did we come up with a mechanical way to translate that. We get into the 40s is when the first digital computer came out, when we had electronics. And I know you guys are like, oh, 40s, that's a long time ago. So my brain says, hey, that's really not that long ago. We get into the 60s and 70s, and suddenly they start getting more popular. Late 70s, early 80s, people started having their own computers at home, a few of them, and they were unbelievably expensive in a lot of cases. But now, everybody's got a computer. You literally in your pocket have a computer far more powerful than what they used to get people to the moon in the 1970s. You have a computer in your pocket more powerful than the space shuttle. In fact, if we go back in time, they built these things called supercomputers back then. Your phone is more capable of that. Now we're all digitally connected. We have all this world around us. Some of that is great. Some of it, I think, is a little scary. So, algorithms, I will let you guys read the history there. So, I will say that I don't think I'm that old. Don't disagree. Anybody ever say, okay, I'm a little old. But when I went to college, and I started college in 1988, in 1988, when I enrolled, we used punch cards to enroll. And that was our only way. We enrolled with a punch card. We're long since that now. So, I would encourage you to read about this. As we get closer to what we're talking about now, things have really started to ramp up. We've went from no electronics in the 30s to now we have all these electronic computers that are on our hip. We've got this World Wide Web. And the world has certainly changed around us a little bit. And in fact, if you look at things like social media, I'm going to say that we have started changing because of some of these things that are out there. We behave differently because of things like social media. And I'm not sure that's always good, but we'll get to some of that. All right, so Python. Let's talk about Python itself. So it's a fairly recent language. It is now the most popular programming language in the world. Interestingly enough. And there's been a lot of derivatives that are similar, but a company or somebody says, hey, let's make an extension or change something a little bit. So the advantage to Python, to me, is it's very English language-like. That's good. It's free. We can use it for free. Again, important. And I think it gives you an overview of what's happening. It's very forgiving. It looks like English. Did I mention it's free? So, the best part, there's also a lot of resources for it. So python.org is kind of the parent home. But if you search for Python resources, you're going to find hundreds and hundreds and hundreds. So Python is what we call an interpreted language. In other words, we change it to that machine code, that zeros and ones, on the fly. So we can run it at any time. The other version of languages is something called a compiled language. Compiled language says we run a compiler and we chew up a program and we put it into zeros and ones and then we store it as those zeros and ones and run it that way. So compiled programs can be faster than an interpreted program, but our computers are so fast now that for most of the stuff that we're going to do, there's not literally any difference. And you can build some pretty pretty good sized programs with Python. So, probably you guys are aware of Dropbox. Everybody's heard of that. That's one of the programs that's out there that was native to Python. So we can do a lot with it. This is what that Python shell, and you're going to see it inside of Cengage also, and then we're going to show you in a couple of weeks how we're going to install it and put it on our own computers. That's what a Python shell looks like. So that shell, it's not very exciting. It just says, hey, this is where we're going to put some content, or we're going to type something. And so in this case, at that shell level here, it's interactive. And this one, I think is interesting. What kind of computer is this one showing on? So yeah, it's an Apple, it's a Macintosh, it's inside a, so the other advantage to Python for me is we can run it on literally anything and everything. So everything from a Raspberry Pi if you had one, an Apple Linux machine, Android tablet you can get a Python interpreter for. So we can run it on everything. It's kind of what we call ubiquitous. We can run it on virtually anything. In fact, if you have a Linux machine, and I don't know if any of you guys are that nerdy, but if you have Linux, it's actually built directly into the core in some cases, or the kernel. So it's very handy for that. So our programs, well, we take an input and we display something. So our first one, a function, so in other words, anytime we have those parentheses, we're putting something into a function. So the very first thing we show typically is a print function, just because that's a tradition. It's very easy to see. And here, we're putting a print function in, and we're saying print, hi there, and notice we put our text in quotes, and it's going to spit back out and say, hey there, hi there. So you will see that. And the more things we put in there, so you can use input statements. In this case, we're saying input your name, and it'll actually allow you to put your name in there. And what you're doing is you're creating a variable. Now, we haven't talked to you about those at all yet, but you're creating a variable called name. And notice, input your name, and then we can output your name based on storing it temporarily in that version. So, there's a lot of little pieces we need to work on in here. And so, we're going to go back in and do some of the homework, and you're going to see some of those pieces. Couple of things to remember. Python, everything that we take into Python as an input statement comes in as a text string. So if I want to use it as a number, then I have to convert it. And so this is what those conversion functions, a couple of them are. So if I use the function int for integer, so in other words, numbers without decimals, or I put float, which is a number with a decimal, essentially. So other languages divide these into long integers, short integers, depending on how big of data you can store there. Python makes it really nice because it only does a couple of those. So we have int, and we can float, and we convert things from text when we do an input to a output that we can utilize. So in this case, this little program here says first equals input a number. Second, we inputted a second number, and notice we put that int function right in there, so we can actually stack functions together or nest them. And then it says, all right, so the second number is 44. All right, so what I would like to do, let me show you one more screen of good stuff. So here's some of our processes. So we have floats, we have integers, we have inputs, and we have prints. So we all know those already. Maybe. All right, so what I would like to do is, because it gives us a nice place to start, I would like to look at Programming Exercise 1.1. So if we can launch that, and if Cengage will cooperate, Alright, so I'm going to start this assignment. Alright, so we're going to go through the assignment, but we're also going to do a couple of other things so that we can see what some of these other powers are as it slowly goes. Alright, finally. Okay, so in this case, we get a shell. Has everybody got a shell up? Alright, perfect. So, in this case, I can see that behind the scenes, this one's actually based on Linux in some version. Doesn't matter to us, though, because that code is going to work exactly the same, whether we're on a Mac, a PC, whatever we're on. Alright, so we had a couple of examples, and I want to look at a couple of them. So I want to do an input, so if you guys can see what I'm doing here and follow along. So I'm going to input, but first I have to do something a little different. So we haven't talked a whole lot about variables, but just assume for now that we can use any name. So I'm going to use first, and I'm going to say equals input. Now, in Python, when I say equals, what I really mean is I'm assigning whatever's to the right of the equal sign into the value of the thing on the left. So in this case, it's a variable called first. So I'm going to take whatever comes over here in my input, and I'm going to shove it into first. Equal doesn't really mean equal. In fact, you'll see later on when we use comparison, we actually have to do this. So we put two equal signs together to make a comparison. So we're going to input. And one of the interesting things is input. I can actually then put a quote mark in here and say input, please input the first number. Now, the biggest issue when we do these is, do I have matching parentheses? Do I have matching quote marks? If I forget those, it's going to yell at me. So let me show you. I deleted that. And what it really did here is it says, I don't know what to do because you didn't end that statement. And so in a lot of cases in the shell, it'll just hang up. If I get hung up like that, Control-C will interrupt my shell, and I can try it again. But, now I got to try it again. So first equals input, please input the first number. Alright, so it's asking me. And I will tell you, I just did something that drives me crazy. I didn't put a space in there, so the blinking cursor is right at the end of that. Okay, but I'm going to enter 45. Now, if I say print first, it's going to print 45. So it stored that as a number, or as a text, but I didn't change it to a number yet. So I want to see what happens when I try to do this. So I can also just do this. So print first times 10, because I wanted to see what it's going to do. Oh, wait a minute. Well, that's interesting, but is that what I was looking for? Ah. So it saw it as text, and it said, oh, you want to print 10 of those. Ah, okay. That might come in handy later, but that's not what I wanted. So I'm going to do this. I'm going to run the function int, and I'm going to put first into it. Now, it didn't look like it did a whole lot, right? But let's try our print statement again. Print first times 10. Why did it not change? Well, let's do this. So let's do first equals first, the integer first, all right, so similar statement, but notice what I'm doing. I'm taking that original variable and I'm saying I'm going to shove in the value of that integer. Just calling that integer didn't really change it. It changed it temporarily, so it passed out the value of 45. And honestly, that is a number versus a text, but it didn't save it for me in that variable. So this allows me to save it in that variable. And so now if I try that print times 10, now I get the actual value I need. So now first has been converted into a number versus being a text input. So that's the first part of how do we start manipulating some of these values. And this version is handy. It is annoying because you have to retype everything. So we're going to show you pretty quickly how we can store those and be able to utilize them a little differently. So this assignment says here's a couple of things we want to look at. These are all math operations. Most of them are pretty normal to you. You've seen 8 times 2, so if we said 8 times 2, we're going to get 16. But if I did 8, so that is the exponent. And that's kind of important, because remember when I asked about 2 to the 8th power earlier? We could have done that inside of our shell. Or we could do 8 divided by 12. So 8 divided by 12 gives us this repeating decimal number. But what if I did 8? So using the double division symbol gives us something a little different. It chops off the decimal portion of the number. It just gives us the integer portion. Well, that could be handy in a lot of different cases. However, I will warn you that if you're going to round something, is that going to round correctly? So really, if I were going to round this, which is a different operation, shouldn't I have 1 if I rounded it to the integers? So it chops that off a little bit, but we use that pretty commonly. So there is also, I don't know if you guys can see my screen there, it's not as huge as I would like. So I could also do this. Move it down here. So there's some other operations we can do, and we can get remainders, we can get all different kinds of other things in math functions. So there are a lot of math functions. So work through those. So that's programming assignment 1. This one isn't for a grade. The rest of these are all graded assignments. So I wanted you to kind of start getting used to this idea. So I'm going to go into exercise 1-2 right now and take a look at what 1-2 is asking us to do. I wish I could make Cengage a little faster, but it does take a while to launch all these. So I want to make sure we're comfortable with this environment, because the second one then adds the ability to put code in here. So now I'm actually storing my file. So notice I have a terminal, I have a place I'm storing code. So this is a little more useful in most regards. And if I come down here in the bottom right, here's the run command. So we have that, and then we have a grading portion down here, so we can see if we need to submit for grading. So on the left-hand side, there's our instructions, our tasks. So here you can get a dedicated view of what you're asking to do. You can actually see how long, how many key presses. So I can also see that. And then we can make it bigger like this, which is most of the time what I do. That way I can see it kind of a half screen. And in fact, you can change that around so it'll fit your size. So I know that what I'm trying to do here is create a file. This file has an extension called .py. So the one issue I will have in here is those of you who are on Macs, if you don't explicitly save it, Macintoshes don't do extensions. Mac is smart enough, like, hey, I know what that file is supposed to run in. But what we want is to store everything as a .py file, just so it will monitor or will move from one platform to another. So in this mode, we have a couple of other things we can do. So notice now I can stack commands up. Up here at the very top is that hashtag character. We used to call it the pound sign, but now we use it as a hashtag. That says, you know what? I'm going to use this as a place I can store text and tell me about what my code is. So if I want to come in here and say, the next line is for points, I can do that. The program ignores this, but these are vital for us because it lets us remember what we did. The other thing it's really vital for in this class is when you start turning in programs as Python files, I want you to put things like this. And that way I can see exactly who it was that did it. And then you can store any kind of notes you want in there. So, in this case, this assignment really wanted us to print, it said, prints your name, address, and telephone number. So 3 items. So let's see if we can do that. And I left in this. Yours shouldn't probably show this print Ken Lambert in Virginia. I did that kind of as an experiment. So my name isn't Ken Lambert, but I can certainly change it. My address and then the next line says I need a telephone number. Well, print, and when I start typing that, here's something that this does that's very handy. Remember I said you needed to match up parentheses and equal signs and all these things to make it balanced? When I type in a parentheses, it automatically puts in a second one, a closing parenthesis. Kind of handy. If I do a quote, it automatically puts in a matching bookend for me. All right, there, I'll give you my Google Voice number. So, now we've created this program. We think this is going to work. Let's run it. Look at that. It prints my name, my address, and my phone number. So I think I'm ready to grade this thing. So I'm like, well, wait a minute, where's this submit button at? Does anybody find a submit button? So we have to figure out where our submit button is, and it's actually under tasks. So what's really nice is I can actually run checks first. So I can run it. It goes over and evaluates my program. And it says, oh, this is only going to give me 66%. And it will actually tell me what the problem is. So this is what it's looking for. What it doesn't like in my name, as far as I can see, is probably the period. So if I take out the period, let's see if that works. So we can rerun this multiple times. So now we're building a program inside of a program that checks our program. So what these do, see these results here, that's really a set of statements to analyze if what you put in here, what this output is, actually looks like it. So you can even show details and see what it was expecting. Now, that probably doesn't mean a whole lot at this point, but we'll get there. We'll get there. So that's assignment 1. I'm going to hit submit, and now I have assignment 1 done. Once it's saved, I can also go back in at any time and look at those. So I can then close it out, and that's assignment 1-2. 1-3, because I know when you first looked, you're probably like, oh my goodness, we have a lot of stuff to do. And we do. They're very small, but I want us to get used to this environment. All right. So this one starts getting a little more complicated. So this one says, evaluate the output and error message of the following code at a shell prompt. Then assign name and appropriate value and evaluate it again. Okay, so what it's wanting us to do, and notice I can copy and paste into that shell, which is kind of handy. So I wanted to say print my name as blank. Now, and it's going to say name didn't get defined. We didn't put anything in there. It's going back up into that memory and says, there's nothing in there. I don't find anything called name. So we need to first then, we need to say something like name equals so what this does is take Mr. Pibb and shove it into name. And then, because I already have that in my paste option, now it's going to work. We tried to do something that wasn't there. Well, it also happens if I do something silly. So, if you're like me, you have a lot of typos, or maybe I'm the only one. And so I meant to type name, but what I really typed was, I forgot the A or something, so I didn't type that correctly. So that's an example of an error we see. And it's going to say, oh, I didn't type it right. Got it. So here's the other secret inside of this shell. If you use the up and down arrow keys, you can scroll through the last few things that you have typed. So I can actually scroll through and do this and get, hey, my name is, and now it's Mr. Pibb. So one of those little shortcuts that our book doesn't seem to show you. So in this case, there's no grade on this particular assignment, just because I wanted you to see what it looks like and how we're getting there. So we're diving in, and we're trying to do it. You are not going to break anything. You can type self-destruct, and it's not going to do anything. It's going to give you an error, but it's not going to blow up the computer. Excuse me. All right. So for this week, there really isn't anything due by Sunday, except I need an assignment turned in. So assignment 1-1 is great. That way I can see who needs to be administratively withdrawn and who doesn't. I would like you to make sure you have your introductions posted. There is a discussion board for week 1. So This first one says, well, I picked Python. What other languages could I use? Are there something better? So I'd like you to go out and do some web surfing and try to see if you can come up with that. You do need to at some point respond to a fellow student. So next week there's a second discussion board due, and the assignments are all due then on the 23rd. So if you wait until Sunday night, probably not good. We do have several assignments, and then there actually is a quiz in here also. So, any questions right offhand? I'm going to